Okay, now another question you'll encounter in the homework is compound interest. And so let me show you all how we do these compound interest type questions. There's two formulas for compound interest. One of them is, if I can get my thing to work here, is this one, and the other one is this one. The first one is for what they say here is in compounding periods. Now what that means is we got compound interest, which how it works is you have a deposited amount of money in some investment, maybe a bank account, and it's earning interest. So the interest that goes into the account uh, then stays in the account, and when you get interest later on, it's paid not only on what you originally put into the account, but all the interest that's been earned up to that point. So these incompounding periods mean how many times per year the interest is being paid. Okay, so that's really what that's referring to here. And there's two different ways of doing it, and there's for incompounding periods or for what they call continuous compounding. And that means we don't have the number n, it just works off of um, the different formula that we have to use here for calculating it. So let me show you all some different situations. We have here semi-annually, quarterly, monthly, and continuously, using the investment of $10,000 for 5 years at a rate of 5.5%. Before I go into the formula, make one quick note that the formula thing up here says R is interest rate, and that interest rate is in decimal. So while I have a percentage here, in a second I've got to change it over to a decimal. The t variable in the formula, that's the number of years. A is going to be the amount that's you have after so many years, and P is the amount that's originally invested, which is called the principal. So the first one, what we'll get here is P is $10,000. I said T is 5 years, so T is 5. And interest rate, I got to change the 5.5% over into a decimal. And just recall how we do that is to shift the decimal point over to the left 2 spaces. And so the interest rate in decimal is 0.055. Alright, now we can plug all this information to the formula to calculate it. Well, we do need to talk about the semi-annually situation here, though. Semi-annually means that it's being paid 2 times per year. So for the formula, we're going to have n equal to 2. Alright, now that's all the information that we need. And I'm going to plug this into the formula A equals P times 1 plus R over N to the N T power. Okay, and this is where the calculator will come in handy, if I can get it to come up here. So, alright, let's plug this part into the calculator. So it's going to go 10,000, open parenthesis, 1 plus 0.055 divided by 2, close parenthesis, and then I press the little exponent button here and put in 2 times 5. And I hit enter, and then that gives me approximation for this situation. So approximately 13,116, and we round to the nearest cent, 0.51. Okay, so that would be the amount that would have been earned, or I should say earned, but the amount that's in the account after 5 years. So you can see that it's grown from the 10,000 to the 13 and something thousand because of the compound interest. Okay, and then quarterly. Okay, for quarterly that means it's paid 4 times a year. So we have n equal to 4 for quarterly. And so if we plug this in, it should come out to be something like this. Okay, I'm going to use 4 instead of 2. Okay, and it should get to something like this. To use your calculator, to make it easy, if your calculator lets you scroll back up, like this one does, you can scroll up, hit enter, and then that brings your last calculation down. You can scroll over to where you had plugged in 2 and replace that with 4. Okay, and then now that we've placed the 4 in, hit enter, and then that would be the accumulated amount with interest with a quarterly interest scheme. So it's approximately 13, 140 point, rounded to the nearest cent, 67. All right, and then the last situation here we have monthly. And if you'd like to now practice what we've been doing, go ahead and pause the video and see if you can calculate the compound interest for the monthly interest scheme. If it's monthly, then it's going to be paid 12 times a year. So the formula will look pretty much the same, but you'll have 4. Instead of having 4, you'll have 12, like so. All right, and that would be approximately, I'll go over to the calculator, scroll up, bring that back down, and now I got to put in 12. Okay, and now it looks like that, and hit enter, and it's gone up just a little bit to 13,157.04 if we round it to the nearest cent. Okay, and now the last situation is continuous compounding. Okay, for this one we don't have n. We have the different formula A equals PE to the RT. So I'll still use the same numbers. I just have to use them in this formula. That'll be 10,000 E to the R, which we have 0.055 times the time, which is 5 years. And so now with continuous compounding, I'll go over to the calculator, put in 10,000, then second, ln, 0.055 times 5. Okay, and now we get a little bit bigger this time, 13,165.31 if we round to the nearest cent. Okay, and so that's compound interest and how we go about calculating it using the compound interest formulas.